Welcome to the Futurisity podcast. This is episode number 6 with Leyla, Loued-Khenissi, Neuro, behavioral and decision scientist. Straight from Switzerland, we'll be talking all about decision making. Why decision making is such a tedious process. How data science and data analytics can help in optimizing the decision making. What is the difference between certainty and uncertainty in decision making? So, great to have you here, and thanks for finding some time for an episode. I'm super excited for this conversation. And why wouldn't you briefly introduce yourself?
Sure. So, as Vlad mentioned, my name is Leyla. I'm a neuroscientist living on the shores of Lake Geneva, and I'm a mother of 3. And I have something of a colorful cultural background. So, I hold dual citizenship with the United States and Tunisia. And I've lived in a bunch of other countries in between. So that's a very brief biography. And yeah.
How long you've been working yet? So in a full-time manner in the science?
So this is a hard one because, like I said, I'm a mom of 3, and I'm also married to another academic. So there have been gaps in my CV, as they like to call them. But I started working in neuroimaging about 20 years ago with PET. And so went through a lot of the developments in neuroscience that we see now. But I'd say like full-time, I would say maybe 15 years of research in brains and cognitive neuroscience.
And you've been working the whole time in Europe or also in the United States, or it was a chronological order?
Yeah, so out of college, I got a position at Columbia University to analyze PET data. So that's more on the neurochemical side, but still brain imaging. PET is kind of a difficult method because it involves radiation. But back then, fMRI hadn't become, the powerhouse method that it is now. So that was my first foray into neuroscience. And then I worked some more at UCLA, this time in fMRI. And then I did my master's in behavioral economics, and then did my PhD in the neuroimaging of decision-making under uncertainty. Yeah. And since then, I've been working as a postdoc, advanced postdoc, so on and so forth. Yeah.
Cool. We'll definitely touch decision-making and uncertainty because I'm really curious about it. And I think it will be a very interesting and controversial topic to discuss later on. Also, the neuroimaging, it will be awesome if you touch this field later on during decision-making part. But before that, we have on this podcast, in literally every single episode, one question, unavoidable. What makes you get up every day in the morning?
Okay. So it's not very scientific, but it's necessary. What makes me get up is my oldest child, because he's the one that has to get out of the house the first. So his school starts rather unfairly at 7:30 in the morning. And in order for him to do that, I have to do that first. So that's the first thing I think of when I wake up. It's like, oh, I have to get that kid out of the house. And it's really unfair because I don't know if you know this, but there's this huge body of research that says that teenagers really aren't supposed to get up so early. And yet here we are. But aside from that, aside from the day-to-day sort of domestic stuff, it's genuinely to get into the lab and get cracking work-wise, to get to work, to try to find answers to difficult questions that, oftentimes have never been posed before, much less addressed.
So you're pushing the boundaries of science with your
I hope so.
Another question. Firstly, why do teenagers, why it's recommendable for them to wake up not so early and maybe in later hours? And the second one, recently I've read somewhere, unfortunately I cannot name the source because I forgot it. I've read somewhere that on average, women need more time sleeping than men. And I was pretty curious about it, like maybe you know something about it. I'll send you later on the source. Maybe we can discuss in the next episode if you don't know the answer.
Sure. So with the teenagers needing, well, they don't. So first of all, they need a lot of sleep, and this is something that other researchers in the sleep arena have found empirically. They seem to need more sleep, and for whatever reason, their circadian rhythm is shifted relative to younger children and adults. And so what they found is that school grades go up when when adolescents get to sleep longer and when they get to get up later. So there have been actual interventions over the past decade, I'd say, in certain school systems where they have started the day much later and gotten these, significant outcomes, positive outcomes out of that. Why? I'm afraid I couldn't tell you. I'm not a sleep researcher, so I don't know about the neurochemistry or anything else that's going on, but we do know empirically that it's better for them. And then for the women versus men, I have to admit, I briefly saw that once, but I don't know much about it at all. And I think relative to the sleep patterns of adolescents, it's probably less well researched, but I hope I don't get dinged on that. So it would be nice if it's absolutely, if it's airtight evidence on that, because I'm a woman. But generally speaking, I have to tell you, Vlad, that I kind of try to stay away from the gender-based research or the sex-based research because we're still struggling as as women to find an equal place at the table, the same place at the table. Absolutely. So so I kind of put that to the side for now. But I'll look it up later.
Because for me, it's not about gender or sex or whatsoever. It's more of a understanding the human bodies in general and how, for example, men and women differ in several patterns or in several, let's say, sleeping mechanisms. So, and if there are any differences, how they impact or influence the day-to-day life. And for me, it's like, I'm trying to investigate that question.
Yeah, of course.
It's like pure curiosity.
Sure.
Can you describe a day in your life as a neuroscientist? Maybe like your typical day-to-day work, including some projects, what you're working at, tools, skills. For example, do you program a lot? Do you do a lot of coding or not? And stuff like that. So it would be awesome if you could elaborate on that a little bit.
Sure. So in fact, the reality is that most of my day is spent coding. And so what'll happen in a typical day is that, over, let's say, several months, we'll have a research question and associated hypotheses. And so we might run an experiment or otherwise collect data to answer our questions. And then I have to get to work digging through that data to extract the evidence I need to answer my questions. My area is cognitive neuroscience, and my weapon of choice, as mentioned, is neuroimaging and mostly fMRI. But I use that often in conjunction with, usually with behavioral tasks and computational models that are meant to better characterize behavior and or the neural response. So in my toolkit, like my toolkit, there's a scanner. I mean, I don't carry a scanner with me.
Yeah, sure.
So a scanner, it's a big magnet. And there's other machines that we can use. So I've used, for instance, eye tracking machines to look at pupillometry. And I've also used a pain stimulation machine. So that was an interesting one. And then, as I said, there's a lot of coding. So first to create these experiments, and that's generally done via Python or MATLAB. And then there's the data analysis that's also done with those two software languages. And finally, there's the really fun part where, if you're lucky, and you're generating these questions in the first place, you'll have this data to interpret, and then you get to write it out as a story and add to this, corpus of knowledge. But yeah, most of my day is spent writing code to streamline my data. Yeah.
Did I understand it right that you work also with a real brain signal? So how do you use a scanner in what you've described?
Okay. So I primarily use fMRI, and that stands for functional magnetic resonance imaging. And with fMRI, so there are different kinds of so with the magnetic resonance imaging, you get different kinds of brain images. You get images that give you different kinds of information, and they're all based on how you get what's called different contrasts. So even though an MRI, like your typical anatomical MRI, the one where you see like a brain in black and white,
Yeah.
It looks like a photo, but it's actually not. It's all based on contrasts. And there, you get into MR physics, which is also not my specific domain. But with functional MRI, that contrast is based on oxygenated or deoxygenated blood. And so it looks at how the hydrogen protons in the brain spin. And so you can measure a difference when there's presumably more activity in the neurons.
Mm-hmm.
And based on that, you can assign a number and, spit out this gradient, basically.
Okay.
So in fMRI, you don't get this nice, crisp, clean anatomical image. You get a much fuzzier image. And then you have to run, software programs to say, okay, well, in this area of the brain, you have, more activity. But so I just want to stress that it's not a direct measure of brain activity. It's an indirect measure. But there's been some work in the past that's, found some correlations and associations that, lead us to believe that we can, use this to answer our research questions. That said, it's a very noisy signal, and that's where a lot of the coding and a lot of the day-to-day comes in to clean it up and to get something meaningful out of it.
I have a question. To which degree do we understand as a humanity how our brain works, like to the closest details?
Oh, wow.
From your perspective.
Yeah, so that's like a really huge question. There was recently, I forget who it was because I'm on Twitter a lot. Somebody said something. I don't even know where they came from, what field they came from, but they're like, neuroscience has given us nothing. And that's not true, and that's not fair. We learn more and more every day, but it's clear that, there's some systems that are very well characterized, like let's say the visual system, down to, the neuronal level, so this microscale level. But then there are other areas where we just, we know a lot, but we don't know enough. So like one example is memory, like, writing a review on the neuroscience of memory is just out of scope, right? Because we know so much about it, but we still don't know, for instance, where like a discrete packet of memory lives, or if it exists at all. You know what I mean?
Yeah.
Like this idea of like deleting, bits of information. We don't know. We don't have that information about something that we use constantly. Same goes for language. Like we know a lot about language via lesion studies, via stroke, we know a lot. We know a lot about the brain regions involved, but we don't know, for instance, and I know language is a very big topic in AI and ML these days, but we don't know, for instance, how a child acquires language with like, comparatively sparse data. We don't know. So to what degree do we understand the brain? Well, someone like me.
it depends. It depends on the domain, probably, as you've said. Like if we're talking about
Yeah,
vision, memory,
yeah,
language, and also probably the age grouping is valid. So
yeah,
it's
yeah. So if you see the brain as a universe, that's how I see it. I mean, we know something, but to what degree, I don't know. I don't know. We don't
so.
know what the self is. We don't know what consciousness is. And it just goes on, which is great because it's fun finding out.
I mean, but it's fascinating, and
Yeah.
it also fascinates me a lot when you think deeply about it. That we don't know, for example, as you've said, what consciousness is, like what is self, and now, as you've mentioned as well, about memory, how we
Mm-hmm.
learn and forget things, like and where they are saved and stored. It's
Yeah.
wow.
Yeah. Yeah. But we're working really hard. I mean, like I'm just one, but the community of neuroscientists is just, I mean, it's just amazing what's being done now. It's just how much is produced. Uh, like I'm in the bath. I mean, in French we say I'm in the bath. Like I'm in the crowd. So
Yeah, I understand. Yeah,
so it's not necessarily always obvious to me. But if I try to step outside of the neuroscience community, it's like, wow, like what we're learning about ourselves is just incredible. And we need we need
yeah.
funding.
But but I mean, a lot of there's a lot of potential for younger people to explore the nature of human brain.
Yeah. Yeah. I think that the questions are, I won't say limitless, but they might as well be. Yeah.
But I mean, after we answer one question, there will be five more,
Exactly.
and probably it's limitless. But let's let's see. Um, Now I'd like to talk about decision making and decision science,
Yeah.
more from the human perspective on the nature of this topic.
Mhm.
Um, Beforehand, some facts, and according to Eva Krokov, lecturer at the University of Leicester in the United Kingdom, our
Mhm.
brain is making upward of 35,000 decisions each day. And some people say that we make on over 200 decisions on food alone each day. That's great. That's mind blowing. However, plenty of the decisions are biased. And another study from Harvard Business Review um, showed that over 70% of senior executives admit to making critical decisions based on gut feelings rather than data.
Mhm.
But what if we could make better decisions on a day-to-day life by harnessing the power of data science and machine learning? So basically, data-driven decision making is becoming increasingly important in today's world, and as businesses and organizations strive to stay competitive and efficient. Um, uh, what I wanted to say is there's a lot of potential to combine both fields and make decision making more rational, more with less risk and more opportunities. So, uh,
Okay.
why is decision making such a difficult process? So that's the question. That's a wrap up.
So, it depends what you mean by decision making, because when we think of decision making, maybe in a kind of prosaic form, we tend to think of like a deliberation,
Hmm.
and that's going to be, roughly speaking, like online memory. It's going to
Hmm.
be explicit. It's going to be you're going to apply reason, maybe explicit logic rules. But there's also the decision making that's not tedious at all, which is automatic. It's fast. You're very well trained to do it.
Hmm.
So this gentleman from Leicester,
Yeah,
you said
it's
that it was
Eva Krokov, yeah, from
okay.
the University of Leicester.
Okay. So most of those decisions, if so, I don't know her paper, but most of those decisions are not things that pass through
Hmm.
your explicit, your working memory, right? That wouldn't be. I don't think that would.
No, I'm not
Yeah.
talking about. I'm not talking about automatic decisions
Yeah.
like brushing teeth or drinking
Aha.
water,
Aha.
but I'm talking about
Mm.
like conscious decision making
Mm.
where you
I know.
have to think rather and choose between option A, B, C, D, or E, for
Okay.
example. That's a decision making I would like to cover in the next half an hour or something.
Okay. So that's from my perspective, from my research angle, there, the subconscious and the like conscious decision making should follow the same principles, right?
Mhm.
So when you see something that's a decision, if I like this thing is blue,
Yeah.
my brain is making that decision to see it as blue, right?
Mhm.
Because this is part of the theoretical foundation that I'm working within, right?
Okay.
So that this is actually like the most likely outcome of a range of possible objects, colors, shapes, and so on.
Mhm.
So that's a decision. But if you're talking about like, this explicit decision making that you see generally with like what we call value-based decision making, which is
Mhm.
usually led by monetary reward. I think that it's tedious in part. I mean, is it tedious? It's difficult in part depending on how much uncertainty is associated with it.
Mhm.
And that's the case for the perceptual stuff too, by the way.
Yeah.
So if like this was turquoise, you'd take a longer time to answer what color it was, right? So so it's clearly like the uncertainty inherent to it, and then when you start getting into uncertainty and like the quantification of uncertainty, you run into this to the maybe the I don't know if it's the first, but one obvious question is like, can you quantify the uncertainty
Mhm.
or not? So when you quantify the uncertainty, generally it's called risk, and there's like a mathematical, or different mathematical quantities associated with that. And then you also have ambiguity where you can't assign it a number, right? So like when you go and play the lottery, you know what your odds are.
Yeah. True.
Yeah, but if we tell you, there might be a car crash tomorrow, that's more ambiguity because
Mhm.
you can't really weight your expectation by anything.
Mhm.
And so we know that humans tend to be more ambiguity averse.
Mhm.
So like they'd rather like know that something bad is going to happen with a certain probability than not know anything at all. So they'll take that option rather than this ambiguous one where the underlying probability might be 90% of having something good happen, right?
Mhm.
So so I guess your question was like, can we offload that to like a huge database using machine learnings?
No.
Yeah.
What I was first of all, I would like to cover such thing as certainty versus uncertainty,
Mhm.
because you've mentioned it, and I think it's valuable for me because I can feel it, but I cannot wrap the proper words around it, like so it will be precise to describe this is certainty and this is uncertainty in a decision making. So can you give couple of examples between decision making in certainty in a certain environment and in uncertain environment? So I think that will be a starting point for the further discussion.
Sure. So uh, there's no such thing as certainty. Sorry.
Okay.
You can have like confidence, which
But I
is like,
mean, if there is uncertainty, there should be some kind of certainty, or at least some degree to certainty.
that's different. Because if you have a degree of certainty, then you necessarily have uncertainty.
Okay, I
So,
like this approach.
yeah. So when you work in this field, I mean, even the field of decision making is very large, but someone like me, from my point of view, there's like never really any certainty.
Mhm.
Okay. And I'm using this like, so there's also a question of nomenclature because some people will talk about certainty and so on. Me, no. There's
Okay.
no certainty that you're always going to be faced with some uncertainty, even if it's very, very low.
Mhm.
Now, there might be a subjective feeling of certainty.
Okay.
So some people will say, I'm absolutely sure that this is the right person to hire. I am sure, I feel it, like you said, in my gut.
Mhm.
That's a subjective feeling. That's not true, right? It's not the
Okay.
ground truth. The ground truth is that even the best person or whatever, you'll put in all these variables and you'll say, this is absolutely the person for me. Could be wrong.
Okay. So from what I've understood, we move always in uncertainty.
Yeah.
Like to some degree, move to some certain environment.
Mhm.
Another question that comes up is how can we navigate from full uncertainty? Let's say I would like to start a new job in a new sphere or in a new field.
Mhm.
I'm not certain about it because I don't know whether I have skills or can I be a good fit from the communicational point, from verbal communication, writing communication, stuff like that. A lot of uncertainty, right?
Yeah.
How can we minimize that uncertainty? In this example, let's say, if I'd
Yeah.
like to start a
Yeah.
new job in a new company, in a new field, from
Mhm.
data engineering to some biologist,
Mhm.
how can I beat uncertainty or at least minimize it so
Mhm.
I can make a proper decision whether I should go for it or better to stay and try maybe at my
Something else.
current
Yeah.
job. Yeah.
Yeah. So it's gaining information, right? So the
Mhm.
more information you gain, the lower your uncertainty. That's how you lower your uncertainty. And the way you gain information, I mean, one way is to learn, right? And so that's why we talk about like learning and decision making very often, because
Mhm.
it's by learning that you minimize this uncertainty. And in fact, the ambiguity I was talking about earlier, this is often what, let's say, a subject in one of my experiments will be facing at the beginning
Yeah.
of a task. And then as they proceed with the trials, they'll gain information with each
Mhm.
trial and they'll learn, some contingency, like a blue square is associated with a 75% chance of winning, and like a red circle is associated with a 25% chance of losing.
Mhm.
So that's how you minimize your uncertainty. And there's some researchers, I won't name them,
Okay.
I don't know, it's there's some idea that, like, we've always thought that the goal of human behavior is to maximize reward, is to maximize fitness and so on. But there's one idea that actually the goal of human behavior is to minimize uncertainty. And therefore, the goal of human behavior is to maximize information gain,
Mhm.
knowing that that gap will never be fully closed.
Okay.
Yeah. So I don't know if
Big,
that
big.
answers your
No,
question.
no, no, no. It's good. Then another question because I'm really curious about. But how? Um, I'll rephrase it. Do you believe in learning by doing? Is it for you also a kind of information gain in terms of beating the uncertainty, or is it something you would say, nah, better read more research papers, more articles, more experiences, more reviews on some specific job, and not go all in with quitting your current job and doing something new? Do you believe in this approach? Because I was
Yeah.
leaving I became 25 last week, and
Happy
my
birthday.
whole my thank you. My 25 years, I was living to 90% uh, with this attitude of learning by doing. That's how I
Mhm.
started in data science. That's how I
Mhm.
landed in my data analyst job back in the
Mhm.
days. Do you think it's also a valid approach into
Yeah.
like forbidding uncertainty?
Yeah. Uh, so this is not my field, so I'm not really talking so much as an expert, but there
No, no, but
is,
from personal
yeah.
perspective, like from your
So,
personal feeling perspective as a neuroscientist.
So I'm going to call on some other colleagues' work, which I'm really interested in trying myself, and that's this idea of like embodiment, right?
Mm-hmm.
So that, you know, when that there's the body is important, and necessarily when you do, then you're not just like in, let's say, quote unquote, a mental process, bearing
Mm-hmm.
in mind that a mental process is also embodied. Yeah. So like,
Okay.
because people tend to talk about mind body duality, and like we're not really in that paradigm anymore. But there is this idea of like reading and so on and absorbing things intellectually. And then I think by doing, you know, you're more embodied, let's say. So you're taking this other approach. And so what might happen when you do and read is you have information coming from different sense modalities in different functional domains. And so maybe either in an additive or multiplicative way, I don't know which, or
Mm-hmm.
both, I don't know, then you might learn faster and better, and therefore, you know, minimize your uncertainty
Okay.
in that sense, I think.
Yeah, because that's how for example, back in the days when I started programming, I had to learn. I
Mm.
was reading a lot about programming, about the fundamentals, about like what is a
Yeah.
function, what is a class, what is a variable. But
Hmm.
when you first touch programming or
Hmm.
any other field, the whole different experience. Like you learn on a whole different level, and
Yeah.
it's uncomparable to what you've read, what you've heard from another people. It doesn't matter. Like from my experience, it's super subjective. It's very important to mention, but from my experience, it it feels like there are two different worlds between
Hmm.
learning with your hands and learning
Hmm.
with by reading by
Sure.
um, listening to some
Sure.
I would.
I mean, there is some basis for this in the research, and so there's this idea of like a trial and error based learning, which I
Yeah,
guess would be
yeah.
more like the doing. And there, the idea is that what you acquire quickly goes into this kind of maybe subconscious or fast automatic, you know, system. And then the reading might be more like, let's say, a model based system where like you read a map and it's very much, you know, not going, you know, you know, going through maybe this more explicit level.
Hmm.
And so like for instance, I have a really hard time with the kids board, well, just board games, you know, because I'm the
Okay.
parent now, so I have to read the rules and understand them. And actually, when you read the rules of a board game, it's really complicated. But then when you play, it's like, oh yeah, this makes sense, right? So yeah, I think that your intuition is probably correct, and probably the best way is to do both. Like, you know, we don't let people like get a driver's license just by learning the theory.
That's true.
Yeah. So
Actually, if we think about it, or at least if we perceive the reality, it's everywhere. Like starting from some applications for new jobs and driving license, and also learning by doing. It's everywhere. You combine theory and
mhm.
practice like all together. Also,
Yeah.
for example, at the university, we had 95% of courses where we had to combine to some degree practical knowledge and theoretical knowledge in one module. So I think
Yeah.
probably
But then
it works.
but then there are areas where we don't get the theory, you know, like really important areas like getting married,
That's for
having
sure.
kids,
That's for sure.
and then it's like you just on the job learning. It's quite
Yeah.
terrifying,
That's
I think.
that's real learning by doing.
You don't have a choice.
Yeah,
Swim.
but um, I
Sorry.
think it's highly personal as well. Like getting married and having kids and stuff like that. It's um, there's enough literature to it, but it's very subjective, I think, and it depends also on personality. Correct me if I'm wrong.
I mean, it's like it's hard enough that there's this huge industry where you can sell books that'll tell you like the marriage part. I don't know as much, but I mean, but definitely with the child rearing and child having or whatever, all this stuff, it's like there's this huge industry of writing self-help books or guidelines or manuals, and it's like I don't know if any of them are worth anything, but but the desire for some kind of theory is there, right?
Mm-hmm.
It's like I don't know, and I need some roadmap or something. So
Yeah.
yeah, so yeah, so I'm
Interesting.
trying to think of edge cases, but it's
Yeah. Um, Another topic I'd like to discuss with you is how data analysis and data science can help one in optimizing decision making. If we're talking from, like, let's take one single person that has no idea about statistics, about mathematics, about algebra and stuff like that, how some basic analytical skills and which analytical skills can help in optimizing decision making. And if we're talking about this decision making, for example, as a job application, yes or no. So what's your point on that?
I mean, I don't know if data science proper would help. Like, so we're talking about individual decisions, right?
Yeah.
So let's say, I don't know. So there are different facets to this. So like so I don't know if this would be a data science approach, but you could imagine that, you have this dilemma and you kind of outsource the dilemma to the net, right? Because usually like what happens is, maybe you can't solve the problem, so you go and talk to your family and friends, right?
Mm-hmm.
But now we have like the internet, so we have a huge source of information and like just a wider range of experience that we can consult to make our decisions. And so that's not like data analysis or data science proper. It's just access to a lot of data,
Mm-hmm.
that can help us in, let's quote unquote, optimizing this decision. But if you're actually going to use, so another thing that could help, I think, an individual in making a decision is really, and I think this is really, really, really important, is to understand probabilities and to understand conditional probabilities.
Mm-hmm.
Because without that, yeah, we're acting a bit, superstitious.
Yeah, I understand. Yeah.
We pull numbers out of our, we don't look it up. We don't see like, like I'm interested in paragliding, and the first thing I went to see was like the injury rate, and it's pretty high relative to other sports, but it's really low in objectively.
Mm-hmm.
So there, it's like I can make a decision. I can make what's called an informed decision.
Yeah.
But I don't know if you need data science. I think you need a good stats course,
Okay.
and you need data. You need a lot of data. You can't just ask your family and friends
No,
and
that's
then
true.
base your probabilities on them, because I don't know how big your family is, but I mean,
Yeah, I understand.
yeah. But then, the problem with taking a very quote unquote rational approach, which is kind of what you were talking about, I mean, there's several problems there. One is that, your optimal solution is only going to be as good as your data, right? So let's say the machine spits out some optimal choice behavior for the optimal solution.
Yeah.
That's going to be based on maybe what was best 5 years ago.
Mm-hmm.
Like, I don't know if data science is going to be, as important in 5 years as it is now,
Yeah, sure.
right? So there's this kind of artificial, like the mean is not static, right?
Uh-huh.
So that's one problem. And the other problem is, like, again, going back to what you said about these CEOs and that, I don't know, these like C-suite guys and
Yeah.
executives and so on, is that the machine is not embodied, right? And I think that we need to feel things, in order to make the optimal decision for us, so
Absolutely.
we need to, so like, let's say a very simple data science way of making the optimal decision is doing a pros and cons list,
Yeah.
and you have the machine expand it, you have it assign coefficients, whatever, weight your list, and then it'll give you some solution, and you'll be like, oh, actually, this is not what I want. I don't know why, but it doesn't sit well with me. And in order to come to that conclusion, you need a body, you need something visceral that tells you that, that's actually not what I want.
It's actually a very fascinating area. What we're talking about right now is how machines are saying one thing, you have to pursue option number one, and the gut feeling says, nope, option number two is better for the whole team, for the whole company, for the whole humanity, society, whatsoever. And it's a very controversial topic, to be honest.
Yeah.
To combine those things so that we make a really optimal decision. So it's fascinating.
Yeah,
We're
because
living in a crazy era.
so yeah, and I think that a lot of my colleagues will probably disagree with me,
Yeah.
but there's been so much talk for years, since Kahneman and Tversky, and even before that to the older guys. God, I can't believe this. St. Petersburg paradox, and all these people that were like, oh, we're not rational because we overweight risk, and so on and so forth. And there's been this emphasis on like a lack of rationality and the biases you were talking about, and how to exploit these biases to get people to make the right decision and so on. And I don't think we're biased.
Really?
Because I don't think we don't have the full model of our behavior. Like we said, we don't know what memories, we don't know what self is, we don't know what consciousness is, we don't know what the complexity of making that decision given all these other people around us. So we don't really know what's optimal.
Very interesting point. Like your view on biases, that we don't have biases. What do you think?
I don't know.
No. I'm curious, but let's say, what do you think about confirmation bias, where we, let's say, I've learned something new, right? And some guy on Twitter or on LinkedIn has written something that is objectively false, like scientifically false. It's disinformation, misinformation, you name it. I believed it, and then the algorithm, now we're talking like from the machine side, suggests me such kind of stuff, and I tend to believe, even if I see like objectively right thing, I tend to believe that this guy has written like a true statement or a true article or a true tweet or whatsoever. Don't you believe we still have this confirmation bias to tend more towards what we think we believe in? Yeah. Or
I mean, yeah, it's true. Like, so it's true. I myself am biased because I am a scientist and I'm surrounded by scientists. So, so my way of operating in the world is, kind of through Popper's view. So it's through falsification. So it's like, as soon as you believe something, you have to go try to disprove it. So of course, if somebody wrote something that was like, like, I can't wait to get off this call to look up this business about women needing more sleep.
Yeah.
So I can get the reference and send it to my husband and be like, you see. But I'm not going to just take your word for it, right? So that's like how I operate and how my colleagues operate and so on. I hope my colleagues operate that way. They probably do. But it's true that like, so it's not like a truth. It's not a principle. It is kind of a guiding principle that I think we don't know enough about human behavior to say for sure that these are biases. Like, even if it is what we would call a bias, it's like, why is it there? Why is the bias there? Why did you believe that thing? Does it address something in you that somehow helps you in that moment? You know what I mean? And I think that to fall back on these ideas of rationality and irrationality, I think is I think we should be more cautious in using those words because right now my project right now is in decoding emotions from neural signals.
Mm-hmm.
Okay. And we don't know that much about emotions. Again, it's another field where there's a lot of research, a lot of theory, a lot of data, but we still don't really know what an emotion is and so on. But for a long time, we didn't study it. You know why? Because emotions were irrational. They were like garbage phenomena.
Really?
Well, yeah, I mean, it was between the Enlightenment and let's say like the early 20th century, it was like there wasn't even the word emotion in English. It was
No, no.
sentiments and passions and all this,
One question: When did people start learning or exploring the emotions or the nature of emotions and considering it as a something rational? 10
uh,
years ago, 20, 40, 50, 100?
so when did they start considering it
Like
something
the first proper
rational?
research
Yeah,
on emotions.
I would like very ballpark was
Yeah,
maybe about 100 years ago, maybe a little less, that people started considering that,
questioning.
yeah, that emotion and cognition are not like,
Yeah,
that they're kind of two sides of the same coin, that
yeah.
of course your emotion is going to influence your decision making as it should because you're a human being. The
Hmm.
emotion has value, it has utility.
Yeah,
If you're afraid, that means you want to save yourself, even if it's irrational. you know Maybe not
interesting.
too much because then you become anxious or some other dysfunctional state.
Also, very interesting topic around emotional intelligence.
Mhm.
That's
Yeah.
also something I don't think people back in the days had awareness of it, that there is
Mhm.
such thing as emotional intelligence. But
Mhm.
I think it's also I don't know how deep you are in this topic or in this field, but maybe we can discuss it in the next episode.
Mhm.
So I already have an idea for an episode for an episode with you, and biases as well.
Cool.
Yeah. Um, what
Yeah,
one
yeah, that's a big one.
Yeah, for sure. I mean, that's
Oh
crazy.
God, I hope I don't get in trouble.
Nah, nah. But it's interesting that emotions are also rational or like rational response of the brain of the body and like to something. It's,
I mean, yeah, I mean, a healthy brain, uh, generally, I mean, if you believe certain axioms in science
yeah,
and the
yeah.
body, a healthy brain it's not gonna waste its energy,
Mhm.
doing something that's not good for you,
Yeah.
right? So if we have these emotions, which are, a very fuzzy phenomenon, in my opinion, it's
Hmm.
very hard to capture. That's what I'm
Yeah,
working on now. Right?
yeah.
Then they have to serve a purpose. They have to serve a purpose.
One thing
They have
that
to have
also,
utility.
yeah, absolutely. The one thing that fascinated me a lot, like half a year ago or something, when I was thinking about vision,
Mhm.
like human vision. And
Yeah.
if we think about the processing, the brain processing of our vision, what we see, we try to forget as many details as fast as possible. Like our brains tries to forget it, and it's as you've said, it's like utility based mechanism of um, process processing the whole bunch of data we see like literally every second, and it's crazy. And I think it's also a big point in, for example, computer vision in self-driving cars. It's very difficult to solve
Mhm.
uh, like on a
Mhm.
large scale for the autonomous driving, but it's
Yeah.
really fascinating.
Yeah. Yeah, it
um,
sure is.
last question before we come to a special rubric. Where do you see the future of humanity in 15 years from now on?
So I think that the future of humanity is bright. I do.
I like it.
And I think that I think we've advanced a lot. I think that that's been partially through technology. I think we can share so much. We have access to so much information. We're wealthier, we're healthier, and there's been a cost to this, So like we see democracy as progress, but there's a cost to democracy and freedom. We know that because it means you have to deal with, like your neighbor who's like maybe kind of a dum dum,
Yeah.
But we can have discussions. We can have discussions, And I think right now, I think the subtext of maybe what you're asking is like, what's going to happen with AI? Like that's like a big question. It's like what's going to happen to us given AI, given these incredible,
Mm-hmm.
progresses in AI, and I think that it's through discussions that we can, agree on how to live with AI. I really think that the future of humanity is bright. I think that it is a question of perspective.
Yeah.
Again, we go back to a good, probability course would probably help people in making decisions because, you should consider the counterfactual. What's the
Yeah.
counterfactual? Like people said, oh, COVID, we did such a bad job, and I'm like, I think we did pretty good. I mean, we weren't killing each other in the street, like like all the other movies with, a crazy virus. Like there's a lot of,
Mm-hmm.
violence in the street, and we didn't have that. People waited in line. Like
The biggest problem here in Germany was with the toilet paper back in the days.
Yeah, toilet paper, which has been around for like not that. I mean, it's just it's the counterfactual. I mean, people are like, okay, well, millions died, and it's like, yeah, but maybe hundreds of millions could have died. Like so this is how I see it, and I think that we could focus on the doom and gloom and the possible, horrors, and I think they do have to be taken into account. But I think the conversation, the fact that we can all talk to each other now, whether we're rich, poor, whatever, this access, there's a lot of noise that comes out of it. Like you said, there's a lot of misinformation, but I think the signal can rise above, and it's better than going back to the olden days where you only had, 2, 3, 4 channels that gave you the news. No.
Mm-hmm. Absolutely, because
I
think we share the same view on the future.
Mhm.
Because I truly believe, and that's also one of the reasons why I started this podcast back in February 2022 is to understand where the ball is rolling, like in the next 10 to 15 years, and not to predict, but at least try to predict what the future. Have this conversation, because I really truly enjoy speaking to people from different industries, from literally different fields, like from neuroscience to renewable energies, like around data and AI and machine learning and technologies, where the future will be in 10 to 15 years, and have this discussion. And I truly believe that the future is bright as well.
Yay!
I really, I don't like the narrative on the media, especially newspapers and all the TV channels and stuff like that. How they, like, it's always bad news, and there's a lot of good things happening literally every minute, but nobody covered them, and I don't understand, like, why. I mean, if we have a look, unfortunately, I don't have the numbers, but if we look at on Africa, now a lot of countries have water access, electricity access, they live longer, they live more happy life. For example, Nigeria is full of IT specialists, and Kenya, I think, as well, partially. We didn't have that in like 50 years ago, and nobody covers that. Nobody talks about like how we really improved several continents and industries and like human life, societies, communities, whatsoever, over the last, let's say, 50 years. And I think it's worth mentioning and worth talking. And I think it's also like very important to appreciate that kind of effort like that we've made over
Yeah.
the last decade. So
Yeah. You're pretty good.
yeah, absolutely. On our Futurisity podcast, we also have our special rubric named Blitz. The idea behind is very simple. I'm going to ask you questions, and you have to answer them without any kind of deep reflection and pondering.
Oh God.
Try to follow your heart and not your brain.
Okay.
Catch the first answers that come to your mind. Okay?
Mhm.
5 questions in total. First, is freedom good?
Yes.
Best single piece of advice for people who want to start in decision science or in neuroscience?
Uh, get probability. Do some
Probability.
probability.
Nice. If you'd write a book till the end of the year, what would it be about?
Be about whatever the opposite of the selfish gene is.
Okay.
Yeah.
And the last one, what is the meaning of life? Did you figure it out?
Nope. No.
But we're trying. It's good.
Yes.
It's good. All right. And thank you very much, Leyla, for your coming and for your time. Thank you for very insightful topics and answers and discussion about decision science and neuroscience and everything around about. I hope to see you in the next episodes.
Okay. Thanks so much, Vlad. Take it easy.
Thank you.
Bye-bye.
So I'll stop recording.